Hey everyone, welcome to this exciting journey into object-oriented programming design. Ever wondered how your favorite apps like Netflix, Uber, Alexa or Google Assistant work behind the scenes? Well, buckle up because today we are diving into the power world of object-oriented programming. Now, object-oriented programming isn't just some boring theory from textbook. It's what makes modern software efficient, scalable and awesome. In this video, we'll break down the four pillars of object-oriented programming, that is, encapsulation, abstraction, inheritance, and polymorphism, using real-world examples from the tech giants you love. You think object-oriented programming is just for programmers? Think again. Your favorite apps rely on it. Let us talk about Netflix. It uses polymorphism to adjust video quality automatically. Let us say what Alexa does with it. It's all about encapsulation to securely process your voice commands. And Uber? You guessed it. Inheritance helps manage different ride types like UberX, UberXL and UberMoto. Trust me, by the end of this, you'll start seeing OOP everywhere. So let's jump right in. Alright, let's talk about encapsulation, the bodyguard of your data. Imagine your phone setting. You can adjust brightness or volume, but you can't directly mess with the system code. That's encapsulation. It keeps data private and only allows control access through specific functions, preventing unauthorized changes and accidental mess-ups. Okay, let's see Netflix in action. Ever wondered why it's not possible to manipulate their subscription plan even directly by some random backend team? That's because Netflix encapsulates its billing system. All account and payment details are logged away and can only request changes through secure APIs. So it means no direct access and no free premium plan hacks. So when these type of questions are asked in interview that what is encapsulation, don't go into very large definitions or something like that. Simply say data protection plus controlled access. And along with that, give some good example like Netflix, which I just explained. Here we tried low-level design of Netflix subscription system and how encapsulation is implemented with simple Java code. If you are not from Java background, no worries. You can easily manipulate it to your desired language. Now let's break down this Java code and see encapsulation in action. First, look at the private variables: plan, user email, and payment method. These are logged inside the class, completely hidden from direct access. You can't just grab them and change your plan. Next we have getPlan, which is a getter. It lets see you plan but doesn't let you modify it. Like checking your movie list, but you can't just add a new one. Then comes upgradePlan, our setter. But there's a twist. It's got a bouncer at the door. Before making any changes, it checks with isValidateUpgrade function, which decides if you are allowed to upgrade, and if not, you won't be allowed. No VIP access unless you qualify. This is what makes encapsulation so powerful. It controls access, protects data, and ensures that only valid operations are allowed. Your code becomes cleaner, safer, and more maintainable. In interviews, just remember, encapsulation is like a security system. Data stays private and access is controlled. For better understanding, I would highly recommend you to practice this code and do your own modifications to understand it better. Alright, let's talk about the second widely used concept, that is abstraction, the secret sauce behind simple and user-friendly apps. Imagine this, you're ordering an Uber, you open the app, enter your location, pick a ride, and boom, the nearest cab is booked. But do you know what's happening behind the scenes? And that's the magic of abstraction. Abstraction hides all the complex stuff and only shows you what you need to see. You don't worry about how Uber calculates fares, how it finds the nearest driver, or how payments are processed. All you care about is booking a ride. Now let's take another example. Google Pay. Sending money is as easy as entering an amount and pressing send. But in the background, It verifies your bank details, encrypting transactions, and securing processing payments through UPI APIs. This is why software companies love abstraction. It makes app simple to use while keeping all the complex logic hidden underneath. Think of it like a car. You only use the steering wheel and accelerator and brake also obviously. You don't need to understand how the engine, fuel injection or transmission works to drive it. And that's abstraction, making technology simple, powerful and user friendly. Let's break down the code for our mock Uber ride system using abstraction. First up, we have an abstract class called ride booking. Think of it as the master blueprint that defines the basic rules every ride should follow. It's like the rule book that all ride types share. Next, we have our concrete classes UberX and UberMoto. These are the actual ride services that step in and implement their own unique booking behaviors, each overriding the book ride method to tailor the process to their specific needs. And here's the cool part: code reusability. Common functionalities like showing a fare estimate are already defined in the abstract class. This means we avoid duplicating code and the system stays clean and efficient. Essentially, abstraction hides the complex details behind a simple interface, letting users just book a ride without worrying about the underlying logic. Now that's abstraction in action, making our code both flexible and powerful. Let's clear up the confusion between encapsulation and abstraction using a fun restaurant analogy. Imagine a restaurant kitchen. Encapsulation is like how the kitchen hides all the behind the scene action. You, the customer, can only see the menu and order your meal, while the chef and all the secret ingredients are kept under wraps. This protects the process and ensures quality, just like encapsulation protects the data in software. Now, abstraction is a bit different. When you order from the menu, you don't need to know how the food is cooked or what secret spices are used. You just see the dish name, price, and brief description. Abstraction simplifies things by showing you only what's necessary, hiding all the complex cooking process. So remember, encapsulation keeps the internal working secure, while abstraction keeps things simple and user friendly. It's like enjoying a delicious meal without worrying about what's happening in the kitchen. It's that cool. Alright, let's dive into inheritance, the secret that lets one class borrow features from another class, just like how you might inherit your parents' eye color or sense of humor. In programming, inheritance means that a child class automatically gets all the common traits of its parent, saving you from rewriting code again and again. Now imagine Amazon as a giant family tree of products. At the very top, we have a product class. This is like the parent that holds all the basic feature, the product's name, price, seller, details, etc. But every product family members adds a twist. For instance, the book class, a child of the product, not only inherits these basic but also includes special details like the author or ISBN. Similarly, the electronics class might add its own attributes like brand or model. This clever use of inheritance keeps the code clean, organized, and super efficient, just like having a family recipe that everyone can improve on. So whenever you see a new product category pop on the Amazon, remember it's just another branch of the inheritance tree, carrying forward the legacy while adding its own flavor. Here we tried to make a mock Amazon e-commerce system using inheritance to make you better understand how it works. In our code, the keyword extends lets a class inherit attributes and methods from another, while super is used to call the parent class's constructor, ensuring shared properties like name and price are properly set. Now let's break down the code. We start with the product class that defines common attributes like name and price and includes a method show details to display these details. Next, the book class extends product, adding its unique author attribute. It calls super in its constructor to initialize name and price, then sets the author and overrides show details to include the author information. Similarly, the electronics class extends product by introducing a brand attribute. It also uses super to set common attributes and overrides show details to show the brand along with the product's name and price. This use of inheritance not only avoids code duplication but also makes our system modular and scalable, much like how Amazon organizes its vast catalog of products. Cool, right? Alright, let's dive into polymorphism, the secret that makes code both flexible and scalable. In simple terms, polymorphism means one thing can take on many forms. Imagine a magic button that performs different actions depending on the situation. That's the essence of polymorphism in programming. First up, we have compile time polymorphism, also known as method overloading. This is where you can have several methods with the same name, but each one is designed to work with different types or numbers of parameters. The compiler decides which method to call based on the arguments you pass, kind of like choosing the right tool from a multi-tool based on the job at hand. Next we have runtime polymorphism or method overriding. Here's a subclass can modify or completely replace a method defined in its parent class. It's like having a standard recipe and then adding your own secret twist when you cook. The base is the same, but the outcome is tailored for a specific purpose. Now let's see polymorphism in action with some real world example. Think of Google search. When you enter a query, the result can be web pages, images or videos. A single search command transforms to deliver exactly what you need, thanks to polymorphism working behind the scenes. And then there's Netflix adaptive streaming. When you hit play, the systems automatically adjust the video quality based on your internet speed and device type. On simple action, hitting play triggers different behaviors, ensuring you always get the best viewing experience. So whether it's multiple methods working together at compile time or dynamic decisions made at runtime, polymorphism keeps our code clean, flexible and super efficient. It's the reason why apps like Google and Netflix can offer such personalized and smooth experience. Remember, polymorphism isn't just a programming trick. It's a powerful concept that transforms how we write and use software. So next time you hit play on your favorite app, think about what is the magic happening behind the scene. Adaptive streaming on Netflix using polymorphism. Let's see by an example how polymorphism works for Netflix. First, let's understand the core idea of this code. Imagine you're watching Netflix on your mobile and it plays in 720p. But if you switch to a big screen TV, it automatically adjusts to 4K. How does Netflix handles this without writing separate code for every device? The answer, polymorphism. Breaking down this code. The parent class video player. This is our abstract class which acts like a blueprint. It has method called play video, but it doesn't define how the video will be played. Why? Because different devices needs different resolution. The child class mobile stream and TV stream. Here's where the magic happens. Both classes inherit from video player but they override play video to adjust streaming quality. Mobile stream at 720p while the TV plays in 4K. Method overriding in action. Even though both classes have the same method name play video, each class provides its own implementation. This is called method overriding, a key feature of polymorphism. Now comes the fun part. We create two objects, video 1 and video 2, but we store them in a common reference type video player. This means Java will dynamically decide at runtime which play video method to call based on the actual object type. This design makes our code super flexible. Want to add streaming for laptops or tablets? Just create a new class like laptop stream, override play video, and boom. No need to change the main program. This is how exactly platforms like Netflix, YouTube, and Prime Videos optimize streaming for different devices. One method, multiple behaviors. That's the power of polymorphism. Next time you're watching Netflix, remember there's some polymorphism magic running behind the scene.
And that's a wrap. You have now got a solid understanding of object oriented design. But here's the real question: how do big tech companies design relationships between objects? Well, stay tuned because in our next episode, we are diving deep into how big tech companies designed object relationships in LLD. But that's not all. At the end of this series, we'll bring everything together with hands on coding practice, applying all the concepts we have learned. So make sure to like, subscribe, and hit the bell icon so you don't miss it. See you in the next one.